Dear students, now we are going to see the course Signals and Systems. Under that, the topic is Discrete Time System Analysis using Z transform. On the completion of this discrete time Z transformation, the students can able to perform the process of convolution between signals and understand its implication for analysis of linear time invariant systems using Z transform. Stability analysis, location of poles for stability. Let H of n be the impulse response of an LTA discrete time system. Now H of n satisfies the condition for stability is summation n equal to minus infinity to infinity. A magnitude of H of n value should be less than infinity. That means the impulse response must be absolutely summable. Then the discrete time system is said to be stable. The stability condition of the above equation can be transformed as a condition on location of poles of transfer function of LTA discrete time system in Z plane. Let H of n equal to a power n into u of n. Now the condition for stability is summation n equal to minus infinity to infinity modulus of H of n. Here substitute the H of n value, summation n equal to minus infinity to infinity a power n into u of n. U of n holds the value of 1 only if n is ranges from 0 to infinity. So the summation limit changes to 0 to infinity a power n. The transformation of this signal becomes 1 divided by 1 minus a, that is a constant. So here the value of a is between 0 to 1 and the system is said to be stable. If the modulus of a value is greater than 1, then a summation n equal to 0 to infinity a power n, its value goes to infinity. So the system becomes unstable. So, Z transformation of H of n is given as Z divided by Z minus a. So, here the pole is located at Z equal to a. If a is less than 1, then the pole will lie inside the unit circle. If a is greater than 1, then the pole will lie outside the unit circle. Therefore, for a stable discrete time system, pole should lie inside the unit circle. ROC of a stable system, let H of Z be Z transform of H of n. Now, by the definition of Z transform, H of Z equal to summation n equal to minus infinity to infinity H of n Z bar minus n. Evaluate the transfer function H of Z for Z equal to 1. We are getting H of Z equal to summation n equal to minus infinity to infinity H of n. Take the absolute values on both sides. So we are getting magnitude of H of Z equal to summation n equal to minus infinity to infinity magnitude of H of n. For a stable LTA discrete time system, the H of n impulse response should be absolutely summable and the transfer function value magnitude should be less than infinity. Therefore, we conclude that Z equal to 1 will be a point inside the ROC of a stable system. Hence, for a stable discrete time system, the ROC of impulse response should include the unit circle. General condition for stability in Z plane on combining the condition for location of poles and the ROC. For a stable LTA discrete time system, the pole should lie inside the unit circle and the unit circle should be included in the ROC of impulse response of the system. Frequency response. In general, the input-output relation of LTA discrete time system is represented by a constant coefficient difference equation, that is y of n equal to minus summation m equal to 1 to n am y of n minus m plus summation m equal to 0 to m bm x of n minus m. Here the solution of the above difference equation is the total response y of n of LTA discrete time system that consists of two parts. In signals and system, the two parts of the solution of y of n are called zero input response, that is y z I of n, and zero state response, that is y z s of n. So the response y of n is the sum of zero input response as well as the zero state response. Zero input response or free space or the natural response using Z transform. The zero input response y is at I of n is mainly due to initial output in the system. The zero input response is obtained from the system equation when the input x of n is equal to 0. On substituting x of n equal to 0 and y of n is equal to y is at I of n is our zero input response. That is summation m equal to 0 to n a m y is at I of n minus m, which is equal to 0 with a naught is equal to 1. On taking the Z transform on the above equation with non-zero initial condition for output from the equation y is at I of z, the zero input response y is at I of n of a discrete time system is given by the inverse transform of y is at I of z. Zero state response or forced response. The zero state response is y is at s of n is the response of the system due to the input signal with zero initial output. The zero state response is obtained from the difference equation governing the system for a specific input signal x of n for n is greater than or equal to 0 with zero initial output. On substituting y of n equal to y is at s of n, we get summation m equal to 0 to n a m y is at s of n minus m, which is equal to 0. That is equal to summation m equal to 0 to n bm x of n minus m, that is 0 with a naught is equal to 1. On taking the Z transformation on above equation with zero initial condition for the output and non-zero initial condition for input, we can form the equation y is at s of z. The zero state response y is at s of n of a discrete time system is given by the inverse Z transformation of y is at s of z. Total response. So total response y of n is the response of the system due to input signal and initial output. Example, determine the response of discrete time LTI system governed by the difference equation y of n equal to minus 0.8 y of n minus 1 plus x of n, when the input is unit step and the initial conditions are y of minus 1 equal to 0 and y of minus 1 equal to 2 by 9. Given that the input x of n is equal to u of n. The Z transformation of x of n is Z transformation of u of n, that is equal to z divided by z minus 1. The given difference equation is y of n equal to minus 0.8 y of n minus 1 plus x of n. On taking the Z transform on the above equation, we get y of z plus 0.8 z inverse y of z plus y of minus 1, that is equal to x of z. Y of z is common, so you keep the y of z as common, and second term is 0.8 y of minus 1, which is equal to z divided by z minus 1. That's our Z transformation of the input signal. Now simplify the signal to find y of z. So y of z is represented by p of z. So the equation becomes z square divided by z minus 1 into z plus 0.8. Now we cross multiply one of the z under the p of z. So the equation becomes p of z by z equal to z divided by z minus 1 into z plus 0.8. Apply the partial fraction. So the equation becomes p of z by z equal to a by z minus 1 plus b by z plus 0.8. So find the a value. A is equal to z divided by z minus 1 into z plus 0.8 into z minus 1 at z equal to 1. Substitute the z value is equal to 1. So simplify that. We are getting the a value is equal to 5 by 9. Similarly, to get the b value, b is equal to, first we substitute the p of z by z value, then z divided, that is z divided by z minus 1 into z plus 0.8, then the pole under b is z plus 0.8, and assume z equal to minus 0.8. Now simplify this and substitute the z value as minus 0.8 and after substituting the z value, simplify this, we are getting 4 by 9 is our b value. Now substitute the a and b value in p of z by z. So the equation becomes 5 by 9 divided by z minus 1 plus 4 by 9 divided by z plus 0.8. Now cross multiply the z under p of z with the numerator of the on the right hand side. So y of z equal to 5 by 9 z by z minus 1 plus 4 by 9 z by z plus 0.8 minus 0.8 z into y of minus 1 by z plus 0.8. Here y of minus 1 is 0. So if you substitute the y of minus 1 here, you are getting the y of z is 5 by 9 z divided by z minus 1 plus 4 by 9 z divided by z plus 0.8. So the response y of n is determined by applying an inverse z transformation on y of z. So the inverse z transform of y of z is given by y of z equal to 5 by 9 1 power n into u of n plus 4 by 9 minus 0.8 the whole power n into u of n. If the y of minus 1 value is 2 by 9, then the equation we substitute the y of minus 1 in y of z. So we are getting 5 by 9 z divided by z minus 1 plus 4 by 9 z divided by z plus 0.8 minus 0.8 z y of minus 1 by z plus 0.8. Here in y of minus 1 substitute its value is equal to 2 by 9. So the equation become y of z equal to 5 by 9 z divided by z minus 1 plus 4 by 9 z divided by z plus 0.8 minus 0.8 into 2 by 9 z divided by z plus 0.8. On simplification of this, we are getting 5 by 9 z divided by z minus 1 plus 2.4 by 9 z divided by z plus 0.8. So y of n value is determined by applying a inverse z transform on the above equation. So we are getting z inverse of y of z is equal to 5 by 9 plus, on simplification we are getting this 2.4 by 9 becomes 12 by 45. So 5 by 9 1 power n into u of n plus 12 by 45 minus 0.8 the whole power n into u of n. That is the final response of the system. Quiz. For an LTI system, the transfer function h of z is 1 divided by z minus 0.4 into z minus 0.2. Here the modulus of z value is greater than 0.5. Then the system is dash and dash. Here the system is causal IIR stable system. Thank you.